All right, for example 3, they've also told us that this line is tangent. So JK is tangent. That means it makes a right angle here at that point of tangency. Okay, we need to find x. Now, this one again is kind of a trick question. Notice right here, this 10 that they gave us, that is in between the point on the circle and K right there. So if they wanted it to be this whole long line, since it crosses this line or this circle right here, if they wanted 10 to be the whole long line, they would have drawn a line from here to here. However, we know that it's not 10 because, let me just erase those colors, because when you look at this, your hypotenuse should be your longest side. So here's my right angle. Notice this should be my hypotenuse. 10 is not longer than 20. So I know that this 10 only goes from right here to here. All right, so do we know this length right here? And we do. Notice my radius is x. So that is going to also be x. That's what I'm trying to find. This is going to be a great fun problem. We're going to have a few x's that we're going to be squaring and doing all kinds of lovely stuff. So I'm going to go ahead and figure out what L to K is. Remember, our segment addition postulate says that if we're adding two segments, or if we're looking for the distance of the whole long line, we can just add the sum of its parts right here. So we're just going to do x plus 10. Everybody okay that LK is just x plus 10 right there? Okay, so when we go through, again, that's our C. We'll just throw in an A and a B right here. So when I do my Pythagorean theorem, my A is going to be an x squared plus b squared, which is 20 squared. That is equal to my c squared. Now, be really careful. This c is this x plus 10. When you square a binomial, so these get grouped together, right here, that whole side is that x plus 10. When you square a binomial, do you remember how many multiplications you have to do? This is just like I'm multiplying it by itself. So I'm multiplying two terms with itself, or two terms right here. So please remember, you're going to have to do 4 multiplications. X is going to distribute to both terms. Actually, let's just do this. X times x is x squared, and then x times 10 is 10x. Okay, so we have to distribute x to both terms. We've also got to distribute our 10 to both terms. So we have a plus 10x, another plus 10x, and then plus 10 times 10, or 100 right there. All right, over here, let's see. Let's go ahead and change this to number. That still is an x squared. 20 squared is 400. So right here, when I'm trying to solve this, let's just write that one more time here. When I'm trying to solve this, we kind of talked, and we'll get into this in a later unit, but we talked about when we have x squareds in a problem, it's a quadratic equation. And that's why we kind of added our last unit in, is to teach how to factor and to solve by factoring. So to solve by factoring, you've got to get it equal to 0. So that's the first thing. If you see an x squared in it, just think, I've got to get it equal to 0. Now, this one's really nice because it actually, when you go to get it equal to 0, it's not a quadratic equation anymore. If I were to subtract this x squared from both sides so that I get a 0 over here, what happens is my x squared actually disappears on both sides. So now it's not a quadratic equation. So now when I clean this up, notice right here, this 400 is on my left. And let's add some like terms. I've got a 10x plus 10x, so that's a 20x plus 100. And let's just go ahead and solve this. This is just a linear equation now. So we just follow our steps. We're going to say, if I want x by itself, we're going to first subtract 100. So I have 300 is equal to 20x. And we're going to undo that's 20 that's multiplied to my x by dividing 20. So x is equal to 15 right here. And then we look at the question. That's all we're asked to do. We're asked to just find x. So go ahead and circle this. If you want to check it, everybody loves to do more math, right? Go ahead and check it. If this x were 15, that would put this side as 15, and that would put this side as 15 plus 10, or 25. And this is actually a variation of one of our famous Pythagorean triples. So if you have a 3, 4, 5 triangle, it is a right triangle. Notice these are all just multiples. If you just multiply all those by 5, I've got 15. 4 times 5 is 20. 5 times 5 is 25. And that's a triangle that we have here, the 15, 20, 25 triangle. So it is indeed a right triangle if you plug in that 15 for x.